The golden triangle. It is an isosceles triangle with angles 36, 72, and 72. Here, here, and here. When an angle bisector intersects at one of the points with 72, this creates another golden triangle, like this one right here. Since obviously triangle ABC and BCD are similar, we find out that AB divided by BC equals BC divided by CD. This putting the values for those in is phi divided by 1 equals 1 divided by phi minus 1. You'll notice that if we put phi divided by 1 divided by phi in place of phi minus 1, then phi divided by 1 equals phi divided by 1, making it so that we know that phi minus 1 equals 1 divided by phi. Back to the problem. After expanding the equation, we can find out that phi is equal to 1 plus square root 1 divided by 2, which is plus because phi is greater than 0. So that means that phi is equal to 1 plus square root 5 divided by 2, which this is the golden ratio. Something else is interesting about the golden ratio is that 1 divided by phi, 1 divided by phi is equal to 2 divided by 1 plus square root 5 equals 1 square root 5 minus 1 divided by 2. Isn't that interesting? Let's have a look at this regular pentagon, A, B, C, D, E. Well, something to note first is that the angle BAE over here is equal to 5 minus 2 times 180 divided by 5, which is also equal to 108. This also means that all the other angles in the pentagon here, 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 and here are all also 180. 1 and 8. Next, let's look at angle DAE, which is over here. The angle that is 180 minus angle DEA over here, since if you look at the triangle DAE, it is an isosceles triangle, so that means this angle over here and this angle are the same thing. This is why this works. 180 minus 108 divided by 2 is equal to, what is it equal to? 36. Angle CAB over here is equal to DAE, so that means it's also equal to 36 degrees. Angle DAC over here is equal to BAE minus DAE minus CAB, which means it is equal to 108 minus 36 degrees minus 36 degrees, which is equal to 72. No, wait, no, it's not. 36 degrees. Whoopsie. Just by only knowing the pentagon, we can find out all the angles of the entire shape. Now let's look at something else. The 3 sizes for each of the golden triangles. The first size is small, which is an example for that is triangle AGF, which is the smallest possible golden triangle. Remember, a golden triangle is a triangle with angles 36, 72, and 72. The second, the medium-sized triangle, one of the medium-sized triangles at least, is AJE over here. That is a medium triangle. A large triangle is one like triangle ACE. Okay. AC. Oops, not C. E. There isn't any other sides to these triangles, but it's interesting to know that in a regular pentagon, you can have so many golden triangles in it. Next, let's find the four lengths that you can find just by assuming that line AB is equal to 1. First of all, BH. BH over here is in this triangle. BH, I probably shouldn't use that color. BHA. Seeing that we already know line BA, which is 1, that means that BH is equal to 1 divided by 5. Next is line HI, which is over here. Line HI is part of this triangle over here. Now but we don't know any of the lengths of these triangles, do we? No, well, actually we do. CH over here equal to BH. Since BH is 1 divided by 5, HI is 1/2 divided by 5 times that. So that means HI is equal to 1 divided by, 1 divided by 5 squared. I don't know why there are equal signs here. Whoopsie. Ah, dang it. Ignore that. Okay. Next is line BI, which is over here. BI is just equal to AB, since BI is part of this triangle BIC. Since this is an isosceles triangle, BI is equal to AB, so it's 1. BD is this line over here. BD is equal to phi, since BD is part of, let's see, another color, BAD, which has the length of AB. So you just have to multiply phi to 1, which is phi.